composition rule. The condition to verify if a function has inverse, the function f of the inverse function f of x is equal with x. And if the inverse function of f of x, function f of x, is equal with the x. So if these two conditions are satisfied, it means the function has an inverse function. Or sometimes if we want to find the two functions, if they are inverse of each other, we can write it this way: f of g of x is equal with g of f of x, and both of them are equal with x. This means if two conditions hold, then the function has an inverse function. Let's take one example here down. So we have two examples, A and B. And let's go first with example A. If f of x, let me go here f of x to find f of g of x first of all. And let's see what we can say here of x. And I'm taking the function f instead of f. Let me write here, here is x. Instead of x here, I will leave it open. And down I will write a 4. And here is a plus 7. Plus 7. And instead of the x here, I am going to substitute 4x minus 7. 4x minus 7. And if we are simplifying a little bit this function here, what's going to happen is going to be x minus 7 over 4. 7 over 4 plus 7. Obviously, we see here we're going to get a positive number that is greater than 1, probably, because 7 over 4 is around 2. But if we want to be a little bit more specific about it, let's find more specifically. Minus 7 over 4. And here, let's say, plus 7 over 4, 28. 4 times 7, 28 over 4. This I can write in the fraction form, the 7 like a 28 over 4. And because of those two fractions, they have the same denominator, I will take as 28 minus 7 is a 21. So x is going to be plus 21 over 4. So here I'm not interested to do anything else, but I know 21 over 4, and this number is going to be different from x. So it does not satisfy the condition, any of this condition here. Because it does not satisfy this condition here, we know g of x is not inverse function of f of x, and neither f of x is a function of g of x. So none of them is function of each other. So let me write no, those are not an inverse function of each other. But if we go to B, in example B, for example, let me go first to f of g of x. Let me solve this way first, and let's see what I get. And here we are going to get this way. And f of x is a cubic. Let me write here one big cubic root. And here is a cubic. And instead of x, this x here, I am plugging x cubic plus 1. Here is a x cubic plus 1. And here is a minus 1. This minus 1 I'm writing here minus 1. But here we see we have a plus 1 and minus 1. We can cancel those two. We can cancel plus 1 minus 1. And what remains here remains, this is going to be equal with the cubic root of x cubic. Cubic root of x cubic. So again, this cubic I can cancel. I can simplify 3 with the 3 here. And this remainder is equal with the x. So it means that the first condition is satisfied. But let's see, does it satisfy second condition? And second condition here is a g of f of x. Of f of x, and this is going to be this way. Instead of the function g, I have x cubic. I will leave this x cubic one empty place here because I have to plug in function f of x. And here is a plus 1 here. And the function g of x, f of x is a x cubic, but here was a cubic because x was a cubic, and here I'm writing cubic. And here, this is a cubic here. And here is a x minus 1. X minus 1. But now this is a cubic here. With the 3 I am going to simplify. What we get here, we get this is going to be equal with the x minus 1 plus 1. And this minus 1 and the plus 1 can be cancelled. We will cancel the plus 1 and minus 1. And the final result is equal with the x. So, and the second condition is satisfied. So the function f of x is the inverse function of g of x, but also the function g of x is the inverse function of f of x. So those functions are the inverse of each other. But in the example A, it wasn't true. But if we wanted this to see from the geometrical perspective, we can see in this figure here. For example, we have a function f of x and g of x here. And as we see geometrically, when we draw the line y is equal to the x, we see the function f and g, those are not symmetrical with respect to the line y is equal to x. So those are not inverse function of each other. But if we look now in example B, what we saw before analytically, and now we are looking geometrically, and if we look in these two functions, those are the function f and the function g are symmetric with each other with respect to the line y is equal with the x. So we are seeing geometrically, and we saw analytically here the b, those are inverse function of each other, but in example A they are not inverse function of each other.